exposure and information you can get can't harm you. All right. So what number did you say? I'm sorry, you said over here.
Number 4 and then 17.
All right, let's hit 17 through 21st.
You said 4. Wow.
Okay. So write the polynomial function of least degree that has those coefficients, the given zeros, and the lead coefficient of 1. Don't forget, complex numbers and radical expressions always have a conjugate 0. Okay? So I gave you I. That automatically means negative I is also a 0. If I gave you negative 3i, that means 3i is an automatic 0. So you have 4 zeros here. Okay? So let's figure this out. So if I have x equals I, and x equals negative I, and x equals negative 3i, and x equals 3i, okay? Now we have to kind of figure out what these equations might look like, okay? So I could do it a couple of different ways. I could realize this is x minus I. Agree? What's this? Okay, so let's do this one first. That's the difference of two squares. So if you do the math, the middle terms drop out, correct? What is I squared? Negative 1, right? So what? X squared plus 1. That's my first polynomial. Okay, that satisfies my two zeros of I and negative I. And then I'm going to do the same thing here. This is going to give me x plus 3i. And this is going to give me x minus 3i. Agree? If I FOIL this out, the middle terms drop out, so I get x squared minus 9i squared. What is I squared? So x squared plus 9. So then I am going to do x squared plus 9x, or x to the fourth, excuse me, plus 9x squared plus 1x squared plus 9. Combine your like terms. X to the fourth plus 10x squared. 10x squared plus 9. So that's what your answer looks like. So the big thing you have to remember, when you have a value that is I, if they didn't give you the conjugate, you have to add that 0 as well. This, as a graph, would have done something like this, where the xy axis is right there. Okay? This is the point 0, 9 because of that. But that's what it would look like. It does not cross the x-axis at all. Okay? Then let's go to number 18. Number 18 is I get 5. Do I need a conjugate pair with this? No, doesn't have an I. And then I have 3 minus root 6. So what this meant is when I used my synthetic division and I found 5, and then I used the quadratic formula to FOIL it out, there has to be a conjugate pair with this as well. So 3 plus root 6. So you had 3 zeros on this. One of them's hidden. So irrational zeros come in conjugate pairs as well. Okay, so let's take care of this. That's going to give me x equals 5, which is x minus 5. Agree? So that zero's done. Then let's figure this out. Equals 3 minus root 6. X minus 3 plus root 6. Is that okay? So that's, I'm going to have to do some nifty stuff with that in a moment. And then I also had this one. I'll bring it up here. So I have x equals 3 plus root 6, which is x minus 3 minus root 6 equals 0. Agree? So the nastier part of this problem is I have to multiply this and this together. this gets multiplied with this. So it's like foiling or distributing on steroids. Okay, the nice thing is a lot of stuff is going to fall out because they're conjugates of each other. Okay? So if I go x times x, I get x squared. Agreed? If I go x times 3, or negative 3, I get negative 3x. If I go x times negative root 6, I get negative x root 6. Is that okay so far? Then I'm going to take the 3, or the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative is going to be positive 3 root 6. Still with me? I'm going to do the next one in purplish. Then I take root 6. I go positive root 6 times x. So plus 6 root x. Okay, oh, I went the wrong way with that. Sorry about that. Root 6 times that is x root 6. Okay, root 6 times that is minus 3 root 6. Root 6 times root 6 is root 36. Root 36 is 6, and it was supposed to be a negative. Okay, let's see what kind of like terms I have here. All right, let's go with fancy yellow. You can see that. Orange. All right. X squared. Any like terms with x squared? No. Cool. Negative 3x and negative 3x. Do all that right? Is that right? Any other x's up there? So that's minus 6x. And x root 6, negative root 6, and that. What happens to those? They're gone. Okay. Let's see. Let's take care of this one and this one. What happens to those? Cancel. And then I get 6 and not 6 or not 9 minus 6. And the unfortunate thing, then you have this to do one last time of distributing. Okay? X gets distributed. Combine like terms, those, and then plus 33x, and that's minus 15.
Wait, shouldn't there be an x to the third in there?
Oh, that was right here. I just can't write. Sorry about that. So that should help you along on those. Okay, you said number 4. Oh, sweet. Negative I? Is that what it is?
Yeah.
Okay. One way I'd look at this problem to do is you can kind of, well, if you know you have negative I as a 0, what's another 0 guaranteed?
Positive.
Positive I, right? Okay. So I know that I'm also going to have, how many solutions does this problem have? 3 total. Do I have 2 of them already up there? Yeah, I have positive I and negative I. Okay? So we can do one of 2 things. We could say, you know what? Let's try synthetic division, see if we can break this down. So it'd be all the factors of 3 over all the factors of 1. Okay, so I'm going to try the 3 first. That's 1, that's 3, that's 0, that's 0. That's 1, that's 3, and guess what I found? Okay, so I have x equals 3, which is this, right? This was third degree. Agreed? This was x third. What is this? What is this?
X squared plus S.
Cool. This satisfies both of those.
Wait, why'd you use a 3?
Why? Because I have all of the factors of 3, so 1 and 3, both positive and negative. And I didn't think it was going to be 1, so I tried the 3 first, and I got lucky. Okay, honestly, what I would do on this, I would put it on your graphing calculator, and if you put it on your graphing calculator, it crosses that 3 right away. That would tell you right now, okay, I'm going to use synthetic division, divide by that 3, and then it gets me my last binomial. So this parabola would look like this. Cross at 3. This would look like this. It's basically what the graph would look like. Okay, where that wiggle is up above is where the eyes are taking place. Okay, and so my answer is this and that multiplied together. Of course, you can make x is not 1x if you want. Yeah.
For number 3, would the x equals 4I be the same as this?
Yeah, you would do the same thing. Okay, so number 3, same idea. What's another 0 got to be? Negative 4i. Okay? So, I would not even mess with this on synthetic division because 64 has an ungodly amount of factors. It has 1, it has 2, it has 4, it has 8, 32, 16, 64. There's a ridiculous amount, and it's the positive and negative components of all. How many zeros does this have? What's my highest degree? 3. How many zeros does it have?
3.
How many are listed up there right now? 2. I'm looking for my last real 0. Anyone have a graphing calculator out? If so, graph y equals x to the third minus 4x squared plus 16x minus 64.
On a test, are we going to be able to use
Yep.
that?
That's the wrong side. And just look at your graph. Do you see a 0 that sticks out right away?
I mean, yeah, but it's
What is it?
like 7.5.
Nope. Make sure you have it plugged in right. Here, let's do this. Going to Desmos. What's my equation? Hang on. Y equals
Not like that.
x or
X to the third.
x raised to the third.
I'm just
X raised to the third
minus 4x
minus
squared.
4x squared minus 16x
minus
64.
minus 64.
Oh, it does come out too. Oh, look at that. Yowzers. I would prefer. Let's do this one other way. One other way. We're not supposed to show you this because some people think that this isn't good math. But it's 4 things, yes? Let's see if I can factor by grouping. What can I factor out of both of those? And I can factor out a 16. And this won't work on all of them. It just happened to work on this one.
This seems so much easier than doing the other stuff.
Well, it won't always work on when it's just. When I looked at it, I realized it was going to factor by grouping. Yeah, I don't know what we're doing wrong on the calculator to get it goofy. It might be the pixels are off on our calculator. But it should, yeah, we should add a 0 at 4. I mean, we should be able to verify that if we go 4 and synthetically divide it. 1, negative 4, 16, negative 64. 1, that's 4, that's 0. That's 0, that's 16, that's 64. Yeah. So I plugged something in wrong for some reason. I don't know why. Cool. So that's my answer right there. Sometimes you could go to factor by grouping on these if it does work. Okay, not every third degree polynomial can be factored by grouping. Anything else?
Can you do 10?
10. Use your graphic calculator. So make sure you have that out, please. So number 10 is Olivia. How many zeros does this have?
4.
Why is that?
Because it's x to the 4.
Yeah, it's my highest exponent. Okay. Can you see any of the places it crosses the x-axis on your graphing calculator? Where? 2?
Yeah, it's -1, -5.
So what's one?
1 and 5.
Negative 1 and 5?
-1 and -5.
Negative 1 and negative 5, it's crossing. Okay? So that's 4th degree, so synthetically divide. So I got 1, I have a 6, I have a 14, I have a 54, and I have a 45. So check. Okay, what degree polynomial is this now?
3rd.
Yeah, because it was 4th, now it's 3rd. Okay, so I'm going to synthetically divide with my negative 5. Okay, sweet. So that means this is x plus 1. This is x plus 5. And this right here is x squared plus 9. So my 0 here is x equals negative 1, which we knew. This is x equals negative 5, which we knew. And this is x squared equals 9, square root both sides, so I get x is equal to plus or minus, and it should have been negative 9, excuse me, 3i.
How do you get 3?
Because if I go x squared plus 9, if I subtract 9, I get x squared equals negative 9. Take the square root of both sides.
Okay.
Bless you.
Yeah, so it's just like that for all the problems?
Life good?
Yeah. Pretty good.
Everyone's happy? So you have a review sheet for Monday. Yes? For Tuesday is our quiz on this stuff. I would think on Monday we would need about half the period for the computer. The other half I will reserve for any review questions you might have come across. And now let me just hand you out this paper. This is not homework or anything. This would have been the notes. There wasn't a whole lot of notes for today, but it's just kind of some of the review of some ideas. Let me ask you all this. Will you all have M done by Tuesday? If so, put a 4 at the top of your paper for me, and being you were here, I will put in the group. Toss those, would you? In the bucket over there.
I'll eat them.
Eat it.
Can't finish
Once you eat it.
I will be here.
Sorry.
Dude. Sorry, Mark. Dude. I will be here today after school. I will be here Monday after school, okay? If you need any extra guidance, Thanks, Grant. And if you have any old homeworks, I'll take them.
Yes, sir.
So letter M, the 4 is at the top. I'll put it in if you were here. Yeah, buddy. Get out of here, guys and girls. Take care of one another. I hope to see you all tomorrow at the game.
Is there
I'll
a
see you on the
computer
field
app
after
for
we win.
the chapter 6 test?
Okay, cool.
Yeah.
Never mind, it's fine, Mr. Syrup.
When can I like see you to like